exam number 6, concepts 6 through 10. We'll start with number 6. Concept 6 was about limits involving infinity. On number 1, we're asked to find the limit as x approaches 7 from the right of x plus 9 over x minus 7. The first thing we would probably try to do is just see what happens when we plug 7 in. We noticed that if we plug 7 in, we divide by 0, which is a problem. So we need to think this one through just a little bit. If we plug a number that's to the right of 7 in, for example 7.001, and subtract 7 from it, we're going to get a small positive number. Agreed? If we plug that number into the numerator, we're going to get a constant that's around 16. If we take a constant that's around 16 and divide it by a very small positive number, what's the result going to be? A very large number, right? And in fact, the closer we get to 7 from the right, the larger this value is going to be. So this is going to infinity. Questions there? Yeah. You could try this with a table of values if you wanted to. Check it out. You could graph it and look at the graph and see that it takes off at 7 from the right. So there are other ways to do this. Number 2. Number 2 gives us the limit as x approaches infinity of 3x cubed minus 4x plus 13 all over 3x to the 9th plus 7x squared minus 6. What do we need to look for here? What's the key on this problem? We're going to infinity. The powers, yeah. We've got a cubic and a power that's 9 on the denominator. What does that mean? Yeah, it's going to 0 because the bottom is so large. The bottom power is so large it's going to take us to 0. Question? Okay. I'll check that after we're done here. Other questions on that? All right, number 7, concept 7. Tangent velocities and other rates of change. We're given an equation here. We're asked to find the equation of the tangent line to the curve at the given point. So right away, I see find an equation of a line. And anytime I see those directions, I think I need a couple things. I need a point and I need a slope. They've provided me with the point, 1, -2. What they haven't given me is the slope directly. I have to go find that. What's the process I need to go through to find that? I need to find the derivative of y, and then put the 1 in to find out what the slope is, the slope of the tangent line at the x value 1. So we just learned this fairly recently. How do we find the derivative of a quotient? Quotient rule. So I always do the denominator first, x minus 5 quantity squared. We keep that denominator, x minus 5. We multiply by the derivative of the numerator, which in this case is nice, it's 1. Minus, now we keep the numerator and multiply by the derivative of the denominator, which in this case is also nice, is 1. So we take a look at this. We're going to have x minus x is going to 0 out. And we're going to have a -5 plus a 4, which will just be -1. So this cleans up to -1 over x minus 5 quantity squared. If we evaluate that for 1, when x is 1, we'd have -1 over 1 minus 5 quantity squared. 1 minus 5 is -4. If we square it, we get 16. So we're going to get a value of -1/16 for the slope. Questions so far? At this point, I've got all the pieces that I need to write the equation of the line. I've got the slope, I've got the point. I can just go ahead and write that in point slope form. Y minus y1 would be y plus 2 equals the slope, -1/16 times the quantity x minus x1, x minus 1. Another form some people responded with was slope-intercept. If you did that, you got y equals -1/16 x minus 31/16. So either one of these forms was fine. questions there? Okay, number 4, same topic. Asks us to find an equation of the tangent line to the curve at the given point. It's basically the same problem, isn't it? They're giving us a quotient. We need to find the slope using the quotient rule again. It's just that this one's just a slightly bit nastier because they're already giving us a square in the denominator. So when we square that, we have to be careful that we actually square that. If we square a square, what do we get? A 4th power. We're going to keep that original denominator, x plus 2 quantity squared, then multiply by the derivative of the numerator, which is 3, minus, now we keep the numerator, and multiply by the derivative of the denominator, which, what are we going to have to do that? We have to do some scratch work here. X plus 2 quantity squared is the same as what? X squared plus 4x plus 4. And if we take the derivative of that, we get what? Right, 2x plus 4. We could just stop right there because all we're going to really need to do is plug 4 into that, right? We could evaluate that for 4, so y prime of 4. If we put in a 4, we've got 4 plus 2 is 6, squared is 36, times 3, minus 4 times 3 is 12, times 8 plus 4 is 12, all divided by 6 to the 4th. I ended up putting that in a calculator and got negative 1/36. You guys verify that? Yeah. So at this point I have a point and I have a slope. I can write an equation. In point slope form, it's y minus y1, in this case y plus 3, equals the slope times x minus x1, in this case x minus 4. If you happen to go and do the extra effort to do slope intercept, you got y equals negative 1/36 x minus 26 ninths. Our next concept is 8, derivatives. This one tripped a few of you guys up. It says f prime of a instead of f prime of x. So we not only do you need to find the derivative, but you need to evaluate it at a, which means plug a in for x. So let's go ahead and just find the derivative first. We're going to follow the power rule here. Negative 4 times 2 is negative 8. Reduce the power by 1. 5 times 3 is 15. Reduce the power by 1. And then the negative 5 is 1 times 5, reduce the power by 1, zeros out the x, x to the 0 is 1, times the constant, just leaves me the constant. That's f prime of x. We were asked to find f prime of a, so that means we need to substitute in a and see what we get. In that case, it's not that difficult, it's just a matter of writing it down. So that would be our final answer for number 5. All right, number 6. Number 6 is similar, except we have to use the product rule again. Thank you, quotient rule. We're going to square the denominator, keep the denominator, multiply by the derivative of the numerator, in this case 2x, minus, now keep the numerator, multiply by the derivative of the denominator, in this case 1. Let's clean that up a bit. In the numerator, 2x times x is 2x squared. 2x times negative 4 is negative 8x. Minus 1 times all that stuff is just x squared minus 3. All over the denominator squared. Actually, I've got a square in the wrong place there. We can do one more clean up on the numerator. 2x squared minus x squared is just x squared, and then we've got a minus 8x and a minus 3. But again, we're not asked for f prime of x, we're asked for f prime of a. So f prime of a would equal a squared minus 8a minus 3 all over a minus 4 quantity squared. That's number 6. Concept 9, higher order derivatives. we've got to find the second derivative of f. I think everyone might have got this one. This one was a pretty good problem for the group as a whole. If we take the first derivative, we should get what? 32x to the 7th plus 8x to the 3rd. The constant zeroes out. And then take the derivative of that for our second derivative. Came out to 224x to the 6th plus 24x squared. And we were done.